Okay, welcome back. In this video, we're going to talk about velocity versus time graphs. Remember last time we talked about position versus time graphs. So this is a little bit different. If you're following along with the video, please have your guided notes open, chapter 2, to where it starts talking about velocity versus time graphs. Okay, let's get started. So it says a car is moving with a constant rightward positive velocity of 10 meters per second. So if we have the picture here, we know it's constant velocity because in the first second he moved 10 meters, second moved another 10 meters, and so forth. So he's on cruise control. Now, if we were to make a graph here, we talked about last time making a position versus time graph. So let me quickly, how would we do that? Position versus time. Okay? Positive or negative velocity here? Positive. Positive. So we better have a positive slope. Is there going to be a curved line? No. No. So we would draw that, a position versus time graph like that. But what we're going to talk about today is velocity versus time graphs. And so they look a little bit different. Velocity time graphs, I want you to draw them like this. So we're going to have velocity out here on the y-axis. We're going to have time here on the x-axis still. This line represents a velocity of 0. So above the 0, obviously, we're going to have positive velocity. Below the 0, we're going to have negative velocity. And so let's think about this, guys. If we wanted to draw a velocity versus time graph for this car's motion right here, what would it look like? Is there positive or negative velocity? Positive. So we've got to be above the 0. We're going to be up here in this region of the graph. How would we show a positive 10 meters per second? Well, we just come up to 10. And what's it going to look like? A straight line. Is the velocity changing over time, guys? Is the velocity changing over time? No. No. So we're just going to keep that as a horizontal line here, a slope of 0. Okay. And so that's what your velocity versus time graph would look like. So we're going to get used to drawing these kind of graphs today. So velocity versus time graphs. Okay, let's now consider the car is speeding up. So it's not going at a constant velocity. Now it's accelerating. So it's going to be accelerating in the rightward direction. Okay, so here's a picture of that car. Now let's draw its velocity time graph. Let me draw it over here again. Okay, so we got velocity over here. Time was on the x. That line represents a velocity of 0, so anything up here is positive, anything down here is negative. Okay, now let's look. Is velocity changing over time, guys? Yes. Yes. Is it going to be positive or negative velocity? So are we going to be up here in this positive region or down in the negative region? Upstairs, because he's going to the right, and in right, in physics, that means positive. But it's changing, right? So how are we going to draw our line? Yeah, there better be a slope to that. It's starting out near 0, and it's speeding up. So velocity is increasing over time. And so you'll get something like that shown there. Okay. So let's just summarize what we've talked about so far. The velocity versus time graphs for the two types of motion. We did constant velocity, would look like this one. And we also showed you what they would look like for acceleration. So, in your notes, you're supposed to write this down. Okay? The slope of a line on a velocity time graph tells you acceleration. So the slope equals acceleration. Slope of the line equals acceleration. What's the slope of this line right here, guys? 0. So acceleration in this instance is equal to 0. Is there acceleration here?
Yes.
Yeah, there's a slope. So it's going to have a positive slope, so it's going to be accelerating in the positive direction. So slope tells you acceleration. Okay, let's keep that in mind. Practice problem number 5. It says below, draw a velocity versus time graph for the following situations. A, positive velocity and 0 acceleration. So we've got positive velocity, that tells you the direction it's going, and 0 acceleration. So let's take a second and do that. Okay, we've got our velocity time graph. This line tells us that velocity is 0. Up here it's positive, down here it's negative. And this line would, the x-axis would be time. So it says positive velocity. Am I going to be upstairs or downstairs here, guys? Upstairs. 0 acceleration. So what's the slope going to be? 0. Yeah, because slope tells us acceleration. So you just have a horizontal line of slope 0. But it's going to have some positive velocity. Okay. All right, let's do B. It says positive velocity and positive acceleration. So take a second and see if you can get that. Draw it. Okay, let's see if you got it right. Positive velocity, so we're going to be upstairs here, and positive acceleration. So will there be a slope on this line?
Yes.
Yes. Positive slope or negative?
Positive.
Positive. So it's just going to be a line like that. Okay, good job. So how can you tell if an object is moving in a positive or negative direction? Well, let's look at this. Both of these graphs on this box here, which side of the velocity are we on? Are we on the positive or negative side here?
Positive.
We're on the positive. On both of these, we're on the positive side. So which way are we going to go? Which way is this object moving?
Right.
It's moving to the right. Because in physics, right means positive. So this guy's moving to the right, and so is this guy. Explain to me what the motion of this object is. Positive acceleration. So he's going right and speeding up. What's this one?
Right and slowing down.
He's going to the right because he has a positive velocity. But what's happening?
Slowing down.
Yeah, it's slowing down. His velocity is getting closer to 0, but he's still going right. Do we see that? So if you're upstairs, you're going to the right. Okay, let's look at this box over here. Both of these lines are downstairs, or on the negative part of velocity. So which way are they going?
Left.
Left. They're both going left, but explain the motion of this first one.
Slowing down to the left.
Yeah, he's slowing down. Over time, it's getting closer to 0 velocity, so he's slowing down. Good. What's this one doing?
Speeding up.
Speeding up, but going to the left, speeding up. Yeah, because his velocity is getting further away from 0. So good job. Okay, how can you tell if the object is speeding up or slowing down? We just kind of talked about this. What's this one doing, guys?
Going away from 0.
Speeding up. It's going away from 0. Yeah, always remember that this line right here equals 0. So if you're getting away from 0, you've got to be speeding up. This guy's speeding up going which way? To the right. What is this guy doing? Speeding up to the left. Yeah, he's got a negative velocity, so he's going left but speeding up. Okay, now slowing down. What does slowing down do, guys? Goes towards the 0 line. So this guy's, explain the motion. Which way is he moving?
Right.
To the right, and he's slowing down, decelerating. Explain the motion of this one.
Left and accelerating.
It's going left because he's got a negative velocity. And is it speeding up or slowing down? Slowing down because what? Yeah, that he's getting toward the 0 line there. Slowing down. Okay, practice problem number 6. Take a second, see if you can get this one. Okay, got a picture of the car. Yep, there you go. If that helps you. Okay, let's see if you got it right. It's moving to the right. So guys, are we going to be upstairs or downstairs?
Top.
Yeah, we're going to be up here where velocity is positive because he's going right. And it's traveling at constant velocity. How do we show constant velocity?
Straight line.
Well, straight line, but explain the slope.
No slope.
No slope, yeah. So we've got, I don't know where it's at, but it's upstairs and it's got a slope of 0. Yeah. And yes, we got it right. Okay, practice problem number 7. Take some time and see if you can get this one. Dawson back there, it's going left. So am I going to be upstairs where positive velocity is or downstairs where the negative is?
Down.
Okay, we're going to be down here. It's going left. It's got negative velocity. And it's traveling at constant velocity. So what is that telling us?
Line, slope line.
Is there going to be a slope to it?
Yeah.
Remember, slope tells us what, guys?
No. Acceleration.
Slope tells us acceleration. So the slope of the line is going to be,
Straight. It's not one.
yeah, it's a straight line, but what's the slope?
It's not one.
Yeah, there's no slope, so it's good. Yeah, good job. Slope is 0. Okay, let's go to number 8. Take some time, see if you can answer this one correctly. Okay, Justin back there. Justin, it's going right, so we're going to have positive or negative velocity?
Positive.
Positive. So we better be up here in the upstairs section of this graph. And it's accelerating. How do we show acceleration? Straight, yeah, you guys keep saying straight, but explain the slope to me. Positive slope. Okay, good job. So if you're going right and you're accelerating, it's going to look, Justin, did yours look like that? Okay, good job. Okay. Number 9, try it. Okay, Carson.
Hello.
It's going right. Positive or negative velocity?
It's up on the top.
It's up on top. Good. We're going to have a positive velocity. But this car is slowing down, so what are you going to do?
It's going down towards this.
Yeah, so it's going to have a positive or negative slope?
Negative.
Negative slope toward the 0, because as time goes on, that car is slowing down or getting closer to 0. Good job. Number 10. Okay, Josie. Car's going left. Positive or negative velocity? Negative. So we're going to be down here in the negative portion of this velocity time graph. And it's slowing down. How do you explain to me how I draw this line? Negative slope. Well, okay, good. Yeah, it's slowing down. So as time goes on, that velocity is getting closer to 0. So it would actually have a positive slope. So let's talk about that. How can you have negative, guys, how can you have a negative velocity but a positive acceleration? It's going left, which means that's negative velocity. But how do you have a positive acceleration? Yeah, you hit the brakes, you got to slow down, right? And that switches our acceleration vector. That's a good example. Good job. Okay, number 11, I think this might be our final practice problem. So try it. See if you can get it right. It's the last one. Okay, Trevor Mincer. It's going left, so positive or negative velocity? Negative. So we're going to be down here in this section of the graph, and it's speeding up. So explain to me how you draw the line. Negative slope. Good. Because as time goes on, we're getting velocity is going away from 0. So we're getting further away from that 0 line as time goes on. Okay, good job. Okay, so here's a summary of the velocity time graphs. This is what we talked about in this video. So in the velocity time graph, the slope represents what, guys? Slope represents acceleration. So in velocity time graph, slope tells you have acceleration. Negative acceleration is also called what? Deceleration. Now the thing to remember about deceleration is it switches your acceleration vector. Whenever you hit the brakes, remember your acceleration gets switched. Okay, and then also, there are never curved lines. You'll never see a curved line with velocity time graphs. Just straight lines. They can have a slope, but they're going to be straight lines. Okay. Before we stop the video, I've got one more slide. I would like you guys to write this down somewhere. I know I didn't include this slide in the guided notes, but at the top of your guided notes, at the side, the bottom, somewhere. These are things to remember about motion graphs. This box right here is for position time graphs. So for position time graphs, the slope tells you velocity. Curved lines tell you acceleration. Okay, that was for position time graphs. Take a second and write that down somewhere. Now the second bullet point, or the second box down here, is for velocity time graphs. In a velocity time graph, the slope tells you acceleration. So it's a little bit different. Remember, slope in position time graph was velocity, but now in velocity time graphs, it's telling us acceleration. And we never have a curved line in velocity time graphs. So you will never see a curved line, at least in my examples. Okay, we've learned enough to do a worksheet in the student workbook. So I'd like you to turn your student workbooks to where it says, the worksheet that says describing motion with velocity time graphs. Describing motion with velocity time graphs. And we'll complete that.